8 different sources of water meet all of Santa Barbara's water needs. Santa Barbara has one of the most diverse water supply portfolios in the state of California. Before the city could recommend how to effectively serve all of its water needs in the future, we needed to understand the complexities of each of the city's current water supply sources. The Water Vision project team completed this analysis in step 2 of the project. Our goal was to identify the highest risks to the city's water supply, so those risks could be taken into consideration as we developed a vision for the future. As you'll see in this illustration, 10 key risks were identified. Some risks affect a single water source, while other risks affect every supply source. For example, increasing energy costs. All the city's water sources require energy, so increased energy costs will impact every water source. However, increased energy costs will have a larger impact on the cost of water from the city's most energy-intensive supplies, including imported state project water and desalination. Another example is natural disasters. A natural disaster like a major earthquake could at least temporarily cut off delivery of supplies from the Gibraltar or Cachuma reservoirs, as well as state project water, into the city's water treatment facility. And finally, sedimentation has increased within the Gibraltar reservoir. In part, this is a side effect of the frequency and impact of wildfires in the watershed. When you have increased sedimentation, that means less water can be stored in the reservoir for city use, putting our reliance on that water source at risk. We then placed each of the 10 risks onto a grid so we could map both the risk's likelihood of happening and its impact on the water cost and reliability. 3 landed in the high-risk quadrant. First, increased sedimentation into Gibraltar Reservoir limits the available supply from this source. Second, climate change, which affects surface and groundwater sources. And third, increased releases from Cachuma Reservoir required to meet environmental regulations and requirements. Now let's break each one of these down a bit. First, climate change. Climate change is putting more shocks and stresses on nearly every water supply source that Santa Barbara depends on. Because we're experiencing more extreme weather variations, that results in higher year-to-year variability of water supply. More extreme drought means we have less surface water available, such as from the Cachuma and Gibraltar reservoirs. And finally, more intense rainfall and flooding could put certain water infrastructure at risk. The impacts of climate change are forcing the city to put more reliance on more expensive yet drought-resistant supplies as the cheaper surface water supplies become less reliable. Second, environmental regulation may require an increase in the volume of water being released from Lake Cachuma to protect sensitive fish species that are downstream of the dam. Lake Cachuma is one of the city's least expensive water sources. As we support wildlife and ecosystems, this means a reduced yield in this inexpensive water in an average year, and even further reduced yield in a drought. Combined, this leaves little buffer in storage to carry over when the city needs it most. The risks associated with these increased releases also force the city to rely on more expensive, non-surface water supplies and indicate the need to obtain additional or new supplies to support the city during drought. And third, increased sedimentation in the Gibraltar Reservoir. Gibraltar naturally captures sedimentation from a large surrounding watershed. However, sediment runoff increases following a wildfire. With severe wildfires increasing in frequency, the result is increased sedimentation to the point where the yield from Gibraltar is reducing at an equally accelerated rate. Unfortunately, increasing the reservoir capacity by dredging or raising the height of the dam aren't cost-effective or environmentally sensitive. Instead, the city may need a federal Warrant Act contract to allow it to store the same volume of water lost from Gibraltar in Lake Cachuma. The city's analysis of future water demands revealed a few important takeaways. First, as you can see from this graph, historical water demand used to be quite a bit higher from 2007 to 2013 than it is today. This is due to several factors, including more efficient buildings and homes, and the community's efforts to make conservation a way of life in Santa Barbara. In fact, what's remarkable is that over the last decade or so, even as population increased, the city's water use steadily declined, speaking to the community's commitment to conservation. What you also see in this graph is that water demand dropped significantly during the most recent drought, reflecting the extraordinary conservation measures employed by the city residents and businesses. Demands are expected to rebound as the community recovers from the drought, and the extent of that demand rebound is an important variable in our analysis. Another important takeaway you don't necessarily see in this graph is that there are significant fixed costs to supplying water to Santa Barbara. No matter how much or how little water the city uses, the fixed cost stays the same. Fixed costs include debt service and operations and maintenance of the city's water infrastructure. The result is that as water use declines, the city's unit cost of providing water actually increases. If the city needs to replace existing supplies or expand those supplies, such as recycled water, further investments will need to be made in that infrastructure, which will further increase the fixed costs. So as we step back from this graph, the city sees a couple of factors that could affect future demand. If we see faster job growth than what is projected, or higher residential growth than what is planned, this will affect demand. But the biggest impact on demand is existing customer behavior after the drought. What if customer demand doesn't bounce back? What if instead the city's customers adopt conservation behaviors that fall somewhere in the middle between extreme conservation and what they've used historically? As part of the Water Vision Adaptive Management Plan, the city will continue to track this demand rebound and adjust actions accordingly. The city has two significant opportunities. First, in wet years, the city has available water that can be capitalized. The Water Vision explores how we could better use the water we already have to create value for the community. As we answer this question, we're considering the following. This water is often available when we don't need the extra water, such as in wet years. And the city's current storage and transport capabilities are limited. Finally, could this available water be used to support environmental water needs rather than human needs? Next, in drought, the city doesn't have enough water to meet immediate needs. The Water Vision explores how we could optimize the role of conservation in our future water supply. Key considerations here include a reminder that conservation doesn't always equate to cost savings. 80% of the costs of providing water are fixed. Also, drought-resistant supplies have varying operational costs, infrastructure costs, and environmental impact. And considering whether there are cost-effective opportunities to conserve further while maintaining the quality of life. Water Vision Santa Barbara aims to find innovative methods to address both of these opportunities.